Good morning everyone. My name is Kishore. I am studying in Karnia University. My URK is 25CS6017. Today we are going to see about the arithmetic operations based on input size and complexity analysis. So what we are going to learn from this is the overflow, incorrect results or insufficient resource utilization in the computer organization and architecture concept. So basically what we are going to do is, in this video I am going to explain about 8-bit or 16-bit conversion of integer and the overflow, whether the overflow is occurring or not based on the input size, and we are going to prevent the overflow of the input size while maintaining computational efficiency. So here this is the algorithm or flowchart of the program we are going to see. So we are going to start the program, accept input and type and also the bit width, and we are going to validate the input whether they are correct or not. So if the validated input is correct, then we are going to perform arithmetic operation and we are going to display the output whether we are getting error. So if we are getting error in validating inputs, we will end the program and we will save output and we will exit from the program. So basically the algorithm is, we are going to read two integer from the user, allow the user to select data with, so basically 8-bit or 16-bit, perform addition using the selected data with, check for overflow condition. So if there is overflow, we are going to also type code to avoid overflow, and whether how to control overflow we are also going to see. So I am going to type this in MATLAB. So the procedure, same procedure also. So we are going to accept a type and value and validate inputs. So we are going to perform arithmetic operation and we are going to display the result. So here is the code we are going to perform. So we are getting two inputs, A and B, and we are getting one more input also, which is choice. So choice with is like 8 or 16 bits. So whether we are going to give 8-bit width or 16-bit width. So if user have chosen 8 bits, then we are going to convert both A and B that we got the input from the user to integer of 8 bits. Then we are going to add both. if the both the added value is less than 255, then there will be no overflow occurring. If the added value exceeds 255, then there will be overflow occurring. So it will, so if the overflow occurs, then we are indicating the user to increase the bandwidth to 16. So then we are displaying the output. Whether if the another one choice, whether if the user has chosen 16-bit, then we are converting both the input A and B into 16 bits integer. Then we are adding both with. So if the both are below 255, here also same, then there will be no overflow in the 16-bit arithmetic also. Then we are going to type the data. We are also going to type the memory value used, total memory used also. So here is the sample input and output. So let me do the code for you. So here it is the code. First we are getting input from the user A and B, then we are getting one more input. So enter whether bit with 8 or 16. Then we are going to the same code I explained earlier. So we are getting choice. If the user enters choice 8, then this code will run, this part of the code will run. Or if the user is selecting 16, then this part of the code will run and everything will be printed. So wait, let me run this code for you. So we are going to enter first integer, then we are going to enter the 16 integer. So if you are choosing 8-bit, then we can see here no overflow occurs. Since the bit width is 7, no overflow occurred in 8-bit arithmetic. Data used type is 8-bit, memory per value is 1 bit, total memory used 3-bit. So let me give you also another code, another case where we can use 16-bit. So let me say 8 and we are going to do it 8-bit. See, here also no overflow occurred. Then we are going to do one more for 16-bit also. Okay, let's say 90 and 78 are going to do in 16 bits. So it will say 16-bit result. So here also no overflow occurred. Data type used 16-bit, memory per used 2 bytes, total memory used 6 bytes. So now we have learned how we can use data bit to control overflow incorrect messages, and also reduce them, and help the user to get the input in a easy way. Thank you.